So I'm doing a quick recording for the class, what's today? April 28th. I forgot to record it in one of the two classes. That's not it. Hold on, let me find what we did. That it? Yes. All right. So copy that down real quick. You can pause it and copy it. I'm going to go ahead and keep moving forward. So we did a quiz where we solved a system of equations. And in the quiz, there were three equations, and each equation was really set up to be solved a specific way. One was set up for graphing, because in the two equations, y was by itself. One was set up for substitution, because in one of the equations, y was by itself, but in the other equation, y was not by itself, and it wasn't super easy to graph for some people. And then in one of the system of equations, it was set up sort of like this, where y wasn't by itself in either equation. So the lesson we did today was just to kind of teach how we could get y all by itself, because a lot of people have gotten pretty good at graphing when y is all by itself. So I just showed you the steps for it. That's what this was. Now I'm going to just go ahead and do an example using those steps. Won't take long. So the first step, it says we want to get rid of this x terms. And we do that by adding or subtracting, and we're going to do the opposite math. So that 3x is positive. So if we're going to add or subtract and we want to do the opposite math, we're going to subtract. I'll do it over here. 3x plus 2y is 10. So I would subtract 3x to get rid of it. So it's gone. But whatever I do on one side, I have to do the exact same thing on the other side. Here's the tricky part, or the sort of tricky part. We cannot combine 10 and negative 3x. There is no way to combine a term that has a variable, the negative 3x, and a term that doesn't have a variable, the 10. All we can do is write this as negative 3x plus 10. So now we break down the 2y. So here's your last, well, I broke it up into two steps. It's really the last step. We need, just like we would in any equation, to get y by itself, we need to divide by 2. So now the 2's divide out. If, though, I divide by 2 on the left, I have to divide every number on the right by 2. I can't just divide the 3 by 2, the negative 3, or the 10. It's got to be both of them. So now I get y equals, I'm going to leave the negative sign with the 3 because ultimately we're going to wind up graphing it. So we would do that anyway. And then you can divide out the 10 by 2 and get 5. Now that equation is set up pretty easy to graph. So again, this will help you just graph every system of equations instead of trying to use substitution or elimination if you were struggling with those. So you can try to do the second equation real quick. This one right here. Pause the video because I'm just going to keep moving forward. I'm going to go ahead and do it. So I need to get rid of the negative 3x. Well, I need to do the opposite. So in this case, I add 3x. So whenever I do it to one side, I got to do the other side. That goes away. In this case, I'm really already done because y was already by itself in that equation in the red box. So I'm really done, but let's say you just wanted to be consistent. You could put a 1 in front of the y, and then you could say divided by 1, divided by 1, divided by 1. So those cancel out. I get y equals, these don't change because anything divided by 1 is the same number. And that's your second equation with y all by itself now. And you could try to graph that. It would be a little tough to graph because your y-intercept is positive 14, and that probably goes off the graph. But you could always change the numbers on the graph to go up by 2. So you could count 2, 4, 6, 8, 10, 12, 14, and then it would probably be on the graph. But there's how you can change equations around to make them easier to graph if you've gotten pretty good at graphing when y is all by itself, using the y-intercept and the slope, rise and the run.